Section 11.1. Solving absolute value equations and inequalities. So we jump all the way from the end of chapter 3 all the way to section 11.1. And the reason we do that is this section kind of fits in pretty well with what we just did. In the last section, we solved linear inequalities. Now we're going to talk about solving absolute value equations and inequalities. So this kind of fits well with what we did right at the end of chapter 3. Let's start with equations. Solve absolute value of x equals 4. Can anybody solve that equation? There are two answers. The two answers are x could be the number 4. How come x could be the number 4? What's the absolute value of 4? 4. Or x could be negative 4. Because what's the absolute value of negative 4? 4. What does absolute value do to a number? Makes it positive. If it's already positive, it leaves it alone. So if I plug 4 into here, it's going to work. Or if the number is negative, like negative 4, absolute value makes it positive, it would give me 4. So there's a very, very big difference between linear equations and absolute value equations. If I give you a linear equation, such as solve 2x minus 1 equals 5, how many answers do you get for a linear equation? You get 1. How many answers do you get for an absolute value equation? 2. Sometimes. And we will see sometimes you get 1 answer, and sometimes you get no answers, which is kind of weird. So there's a huge difference between linear things and nonlinear things. Linear equations, like 2x minus 1 equals 5, always have 1 answer. Nonlinear equations, weird things can happen. In this case, we have 2 answers. I'll give you some examples here in a minute where we only have 1 answer, and then I'll give you some examples in a minute where we have no answers. So for nonlinear equations, weird things can happen. Well, we might as well solve this one here. 2x is 6, x is 3. All right, let's go back to our absolute value equations. Solve absolute value of x plus 1 equals 6. Can anybody tell me an answer? X equals 5 is an answer. Because if I plug 5 in, 5 plus 1 is going to give me 6. And the absolute value of 6 is 6. So there's one answer. X equals 7 is not an answer. Negative 7. How come negative 5 isn't an answer? How come I just, up here we just got to go x equals 4, x equals negative 4. If I plug negative 5 in, what's negative 5 plus 1? Negative 4. The absolute value of negative 4 would be 4. It doesn't work. Yeah, because we got this addition in here, it's not just going to be 5 and negative 5. The numbers aren't always going to match. The numbers are only going to match when I have just an x inside my absolute value symbol. So the other answer here is x equals negative 7. Because if I plug negative 7 in, what's negative 7 plus 1? Negative 6. And then when I do absolute value of negative 6, I get 6. All right, so how do we kind of do this if it gets more complicated? What if I asked you to solve absolute value of 3x minus 1 equals 7? That's one that you probably can't do in your head. Well, maybe you can. Anybody tell me an answer? 4? I don't think 4 is an answer because 3 times 4 would be 12. 12 minus 1 would be 11. Negative 2. 3 times negative 2 would be negative 6. Negative 6 minus 1 would be negative 7. An absolute value of negative 7 is 7. So Negative 2 is a correct answer. Very good. So there's one of the correct answers. Anybody tell me the other one? No, there's another one.
Can't you solve it?
I can solve it. Very good. How do we solve it?
You just do it. I don't remember how you get those away.
All right. So how do you get those away? That's the whole key. How do you get rid of the absolute value? Just for a minute, let's pretend I gave you absolute value of y equals 7. So instead of 3x minus 1, I just wrote the letter y. No. So forget about this equation for a minute. Absolute value of y equals 7. You would tell me the answers are? Positive 7 and 7. So you would tell me the y is 7 or y is negative 7. Nope, you do not negate what's in the absolute value symbol. You negate what's out here. So we left the 7 alone, and we negated the 7. We had the negative 7. So what happens now when we have 3x minus 1 in here? Well, what can happen is 3x minus 1 could be the number 7. Correct? Because if 3x minus 1 is the number 7, what's the absolute value of 7? No, what's the absolute value of 7? 7. So whatever's inside the parentheses here, 3x minus 1 in this case, could be the number 7. The other choice is whatever's inside this parentheses, 3x minus 1, could be the number negative 7. Those are the only two numbers that have absolute value of 7. Or 3x minus 1 equals negative 7. That's how you get rid of those absolute value things. You end up writing two little equations. The thing inside the brackets could be the number 7, or the thing inside the brackets could be the number negative 7, because those are the only two numbers that have an absolute value of 7. Then you have to solve each one. No, I don't think you get negative 2 and 2. Add 1 to both sides over here, you get 3x is 8. Divide by 3, x is 8/3. And then this one over here, you add the 1, 3x equals negative 6. Divide, that one gives you the x equals negative 2. There are your two answers. These two numbers, negative 2 and 8/3, these two numbers will almost never match. When will the two numbers match? One will be positive and one will be negative. Only when your equation is very, very simple, when it just has the letter x inside the absolute values. Otherwise, the numbers at the end are not going to match. You're going to get two different answers. All right, let's try another one. Absolute value of, oh, I don't know. Give me some expression. Anybody got an expression they like? Like big numbers? Sure, why not? 25x minus 36. I don't know if those are big or not. Fairly big. Equals, what do we want it to equal? Make up a number. Doesn't matter. 14. Usually these problems aren't going to have real big numbers. I mean, there's not usually going to be anything in the thousands or anything like that. They'll be fairly small. All right, what do? We need to get rid of these absolute value things. How do I get rid of these absolute value things? I make two equations. So I'm going to have 25x minus 36 could equal 14. Or, whatever's inside the brackets, 25x minus 36 could equal negative 14. So it's always going to end up like that. You're always going to have equals the positive number or equals the negative number. And then you just have to solve each one. Add 36 to both sides. 25x is 14 plus 36? 50. And this one works out real nice, even though we just kind of picked random numbers. X is 2. It's a happy little accident. That's nice. It doesn't usually happen. Over here, we have 25x equals, we add 36, negative 14 plus 36, 22. So So x is, this one's not so nice, that's okay. Now it's positive 22 over 25. Because we added 36 to both sides, negative 14 plus 36 gave us 22. So notice, it's okay to have two positive answers. The problems we did before, it happened to work out that we always got one positive and one negative, one positive and one negative, one positive and one negative. But that doesn't have to happen. Here we got two positive numbers. That's okay. Nothing wrong with that. It gets slightly harder. So let me make it slightly harder. The way it gets slightly harder is if I put some junk outside of the absolute values. So let's say I were to do 3 absolute value of 2x plus 4 minus 1 equals 8. What you really want to do is you want to get rid of those absolute values. But before you can get rid of those absolute values, you have to do a couple things. What you need to do is you need to do a couple of steps and get the absolute value thing all by itself. So we're going to do a plus 1 and then we're going to do a divide by 3. But anytime you have stuff outside the absolute value, that's what you need to do. You need to get the absolute value all by itself first, and then you can get rid of it. The big mistake students will make is they'll take this, so they'll write 3 absolute value of 2x minus 1 equals 8, 3 absolute value of 2x plus 4 minus 1 equals negative 8. And that doesn't work. You need to get the absolute value alone before you can write your two equations down. Okay? So that's the complicated thing. That's the thing also mistakes on. So we're going to add 1 to both sides. 3 absolute value of 2x plus 4 equals 9. Divide by the 3. Absolute value of 2x plus 4 equals 3. I divided by 3. So I added 1 at the beginning to get rid of this 1. And that gave me the 9. And then this 3 was a multiply. So to get rid of the 3, I had to do a divide by 3. No, because I'm adding it to both sides. Over here, the 1 cancels with the negative 1. All right, so there's your first couple of steps. Your first couple of steps are get that absolute value thing all by itself. Now we're ready to get rid of the absolute value thing. So what do I write next? 2x plus 4 equals 3, or 2x plus 4 equals negative 3. And now we have two very simple little equations to solve. We should almost be able to do these in our sleep at this point. Subtract 4 on both sides. 2x is negative 1. X is negative 1/2. And over here I subtract the 4. 2x is negative 7. X equals negative 7/2.
What if, like that, when it came to divide by 3 on both sides, what if it didn't come out with the even number?
Then you'd have more fractions to deal with. And that can happen. Let's do that. I'll make one up where that happens. So let's say we had 4 times the absolute value of x minus 3 plus 6 equaled 11. Same idea. The first thing you need to do is you need to get the absolute value thing all by itself. So what are the steps you go through to get the absolute value thing all by itself? Minus 6 on both sides. 4 absolute value of x minus 3 equals 5. And then we divide by 4. Absolute value of x minus 3 equals 5/4. And unfortunately you get a fraction there. That can happen. You just got to live with the fraction at this point. We get rid of the absolute value symbols. X minus 3 equals 5/4. Or x minus 3 is minus 5/4. And here's where the fractions are kind of a pain in the neck. Add 3 to both sides. X equals What's 3 plus 5/4? 17 over 4. How'd you get 17 over 4? I used my calculator. That's correct. 3 plus 5/4. Your calculator is going to tell you that. And then you can go math, enter, enter. 17/4. Correct. What the calculator did is it got a common denominator and it added them together and did all that kind of stuff. But that's the beauty of having one of these calculators is you don't need to really do all that. You add 3 to both sides here, you're going to have 3 minus 5/4. The calculator will tell you that's 1.75. Or it's 7/4. So the fact that you end up with a fraction over there should not be a death sentence in any way. Use your calculator. Calculator will handle the fractions for you nicely. Questions about that? Sure. I just took 3 minus 5 divided by 4. To get a fraction, you just use the divide button on your calculator. And you hit enter, and it's always going to give you the decimal first. And then if you want the fraction, you hit the math button, which is right up here, math. And the very first option is switch it to a fraction for me. All right, so don't let fractions bother you. Speaking of calculator, we haven't done a lot of this with our calculator. Let's go back to this problem just for a minute. 3 absolute value of 2x plus 4 minus 1 equals 8. We haven't done a lot of solving things on our calculators this semester. Let's take a look at that one. How do you solve an equation like that on your calculator? You go to y equals. Oh, and I got some crazy stuff typed in. I'll erase that. You type in the equation. So I'm going to have 3. All right, now, where on my calculator is the absolute value symbol? It's hidden, actually. It's hidden in a couple places. The easiest place to get it, I think, is to go second and then the number 0. The number 0 gives you a catalog. It gives you a list of everything the calculator can do. And the very first one happens to be ABS, which stands for absolute value. In my calculator, since I have the newer type system, actually puts the absolute value bars in for me. If you have an older calculator, what does it do? It puts ABS with a parenthesis, right? So then you type in 2x plus 4. And if you have an older calculator, you then have to close the parenthesis. Mine types in the bars for me. I got a new one. Minus 1. So I type the left-hand side of my equation in as y1. And then I go down to y2, and I type in the right-hand side of the equation, which is just 8. That was pretty simple. Then I draw a graph. Zoom 6. So what am I trying to find? I'm trying to find 2 points, actually. What 2 points am I trying to find? Where the line intersects the big V. An absolute value graph will look like a big V. So this is the left-hand side of the equation. The horizontal line is the right-hand side of the equation. I want to find where those 2 graphs intersect. Well, we've done this before, haven't we? How do I find where 2 graphs intersect? Trace would be okay. Trace would give you a pretty good answer, but there's a better way. We did this when we did the graphing method for solving systems of equations. Second trace puts me into the calculate menu. And how do I find the intersect? I go to number 5. It asks me, is that the first equation? I guess so, right? It's got the absolute value. I can see the absolute value thing written up there at the top. So I hit enter. It asks me, is it the second equation? Yes. Give me a guess. Well, right now I'm over here, if I use this as my guess, which one do you think it's going to find? And the answer right next to it, probably. So I hit enter. It tells me x equals negative 0.5. So that's what I would write down. I would write down x equals negative 0.5. How come I don't write down the y number? I'm not looking for the y number because this equation only has x's. There's no y's in this equation. I don't care what the y number is. And then I have to go through the same process, do it again, except now I need to make my guess be over here somewhere so it'll find that answer. So I go second calculate, down to intersect. Is that the first curve? Yes. Is that the second curve? Yes. A guess. So I'm going to come over here close to this one. X equals negative 3.5. There's my two answers. Correct. In fact, we did get the same answers if we did it the other way. We just wrote them as fractions. X equals negative a half. That's negative 0.5. And here we got x equals negative 7 halves. That's the same as negative 3.5. So the calculator, fortunately, gave us the exact same answer as we got when we did it by hand. Questions about that? Oh, there's more to go. All right, so I warned you a little bit ago that when we do absolute value equations, we notice that here we get two answers. And I think I told you it's possible to only get one answer. And then I also told you it's possible to get no answers at all. So let's see when that happens. What if I were to give you absolute value? Oh, let's put a 5 in front of it. 5, absolute value. 2x plus 6 minus 3 equals negative 3. Once again, you recognize that you have an absolute value, but you've got some stuff on the outside of it. So the first thing you need to do is you need to get rid of this stuff. So what do you do to get rid of the stuff? Plus 3 on both sides. 5, absolute value of 2x plus 6 equals 0. Divide by 5. Absolute value of 2x plus 6 equals 0. All right, so this is a special equation. When you have absolute value and you have 0 over here, something different happens. What happens? 2x plus 6 could be what? The only choice is 0, because the only number that has absolute value of 0 is 0. So this is an example of where you only get one answer. So if you have absolute value equals 0, you'll only get one answer. In this case, it's x equals negative 3. We would have 2x plus 6 is 0. 2x is negative 6. X is negative 3. So there's an example of absolute value equations sometimes only have one answer. And they will have one answer when you end up with absolute value equals 0. That's when you'll only have one answer. And then I think I told you that sometimes these equations have no answer. How's that going to happen? Absolute value of x plus 1 equals negative 4. That one has no answer. How come? On the left-hand side, the absolute value thing is always going to give you what kind of answer? It's always going to give you 0 or a positive answer. Is there any
way a positive thing on the left can equal a negative thing on the right? No. So our answer would be no solution. So you got to watch out for these trick questions. If I give you an absolute value equals 0, that's where you're going to get one solution. If you end up with an absolute value equals a negative number, that's when you're going to have no solution. All the other problems where an absolute value equals a positive number, you'll get exactly two solutions. What I'll see a lot of students try to do is they'll actually try to solve this. They'll just go blindly the way they've gone all along. They'll write x plus 1 equals 4, or x plus 1 equals negative 4. And they'll go ahead and they'll solve both the equations, x equals 3, x equals negative 5. But of course, if you go back and check, it just doesn't work. If you plug 3 in, you get 3 plus 1, which is 4. Absolute value of 4 is positive 4, not negative 4. So again, watch out for these. Watch out for these trick kind of questions where I give you a absolute value equals a negative number. That simply cannot happen. Your answer will always be no solution. Not sure what I was saying here in class. Probably more the same thing. Alright, so what if you have like negatives on both sides like that? Well, that's going to be okay, because when you divide through by the negative 2, when you get the absolute value thing all by itself first, you're going to have absolute value of x plus 1 equals 2, and that's an equation you can solve. So that's okay. So just because you have a negative number on the right at the beginning doesn't mean you've got a no solution. You've got to get the absolute value thing all by itself first. Once you have the absolute value thing all by itself first, you've got to look at that number. And in this case, that number is positive, so that's going to work. Again, not sure what I was saying in class. Probably just repeating more of the same thing. Now, somebody asked, what if that started as a positive 4 over there? Well, now when you divide by the negative 2, you get absolute value of x plus 1 equals negative 2, and that one would be no solution, because we would have our absolute value equals a negative number, and that simply cannot happen. Alright, now, I think we move on to inequalities. So let's start with one. Absolute value of x less than or equal to 3. And what I asked the class to do was to give me some numbers that I can plug in for x that would make that inequality true. And so we listed a few. We decided that some possible solutions were 1, 2, 3, but we decided 4 did not work, because if I plug 4 in, I would have absolute value of 4 less than or equal to 3. That would be no good. Of course, it doesn't have to be 1, 2, and 3. It could be decimals and fractions in between would work, like 1.6, 2.8. And then we decided 0 would also work. Absolute value of 0 would be 0. 0 would be less than or equal to 3. And then let's talk about negative numbers that might work. What kind of negative numbers could you plug in? We decided we could plug in numbers like negative 1, negative 2, negative 3. Because again, the absolute value of negative 2, for example, would give me 2, and 2 is less than or equal to 3. But that was all these kinds of numbers we could use. So we decided that the biggest possible number we could plug in was the number 3, and the smallest possible number we could plug in was negative 3. And of course, we can plug in any number in between. Again, we can use fractions, we can use decimals. So again, we could use a number like negative 8.6325 if we wanted to. That would be perfectly fine. So what we wanted to do was get an idea of how would we write this solution. 3 is the biggest number, and negative 3 is the smallest number, and all the numbers in between. Well, we started by thinking about what this would look like on a number line. On a number line, my biggest number would be 3, my smallest number would be negative 3, and I would have dots on both of those since I have the equal, and I would shade in between. All numbers in between negative 3 and positive 3 are going to work. So this reminds me a lot of what we did back in section 3.5, the last section. We can take that number line and write it as an inequality. So our answer would be negative 3 less than or equal to x less than or equal to 3. So notice what happens here. when you start with an absolute value inequality and the inequality is a less than, the x gets trapped in between the two numbers. The x is trapped in between -3 and 3. Same sort of deal is going to happen here. If I have absolute value of x less than 7, then numbers that would work would be numbers like 1, 2, 3, 4, 5, 6. 7 would not work this time because I don't have the equal to, but I could have numbers bigger than 6 still, so it doesn't just stop at 6. I could have numbers like 6.5 and 6.89. So my biggest possible number is anything smaller than 7. On the other hand, I can have negative numbers like -1, -2, -3, but the furthest down I can go is -7, but again, I cannot equal -7 because we don't have the equal to sign. So once again, notice what happens when you have an absolute value and you have a less than sign. The x ends up being trapped in the middle, in between the endpoints. In this case, the second problem, the endpoints were -7 and 7. The same thing's going to work if you have an absolute value with a less than, but you have something more complicated than just x inside. What's going to happen here is whatever's inside our parentheses, inside our absolute value bars, the biggest possible number it could be would be anything less than 5. For example, 2x minus 1 could be the number 4, or it could be the number 3, or it could be the number 4.86. The biggest possible thing is 5, and conversely, the smallest possible thing it could be is -5. So our 2x minus 1 is trapped in between -5 and +5, and these are exactly the types of problems we learned to solve back in section 3.5. And so I think as a department, when we decided to write up our syllabus and we decided to put section 11.1 right after chapter 3, I think this is why we did it. Because we just learned in chapter 3 how to solve these problems, so it made sense to continue on and do it right here. What we need to do now, of course, is get the x all by itself in the middle. So we add 1, we do it in all 3 places. We got -4, less than 2x, less than 6. And then, of course, divide everything by 2. Our answer would be -2, less than x, less than 3. Alright, not sure what's going to happen next year. I don't know if I did another example with less than. No, I guess I'm going to talk about this one a little more. Again, what happens is the thing inside your original absolute values gets trapped between the two numbers, and then you solve just like you did in section 3.5. Now I think I'm going to move on to a greater than problem. Let's see what happens with an absolute value and a greater than. So again, I think we start with a fairly simple one here. Let's see what I wrote. Absolute value of 3x minus 9, less than or equal to, I guess I stuck with another less than example, 12. Again, the idea is whatever we recognize we have an absolute value, we recognize that we have a less than, so whatever's inside our absolute value is going to be trapped in between the biggest possible value, which in this case would be 12, and the smallest possible value, which would be -12. From there, pretty standard. We've solved a bunch of these now. We should be able to do it pretty quickly, pretty easily. We add 9 to all the spots. -3 less than or equal to 3x, less than or equal to 21. Divide everything by the number 3. And we get -1 less than x, less than or equal to x, less than or equal to 7. Now, one of the students asked, if that 3 had been a -3 and we had to divide everywhere by -3, would we still flip those inequality signs? My answer was absolutely, yes. Those same rules that we had from section 3.5 still apply. Every time you divide by a negative, you have to change the inequality signs that show up. Didn't happen in this problem, but it certainly could happen. I think that's what I was talking about right here, is that if I divided by a negative number, change the inequality symbols. All right, now I think we're ready to go on to greater than problems. Absolute value of x greater than or equal to 5. And again, I think a good way to start learning how to solve these is to list some numbers that would work. So some numbers that would work would be x could be the number -5, +5, +6, +7, +8, and it could go on forever. And the negative numbers that could work, and of course all fractions and decimals between 5 and 6 and 7 and 8 could work, and it goes on forever. Negative numbers that could work are -5, -6, -7, -8, so on and so forth, going forever. Once again, let's think about drawing a number line and see what that would look like in a number line. Haven't drawn the number line yet. Somebody must have asked me a question about something and I was answering the question. Don't remember what the question was though. Alright, here comes the number line. So on a number line, we would mark the numbers 5 and -5. They would both get dots because they have the equal to on them. And our answer was all the numbers bigger than 5, so I shade to the right. And then a dot on -5, and then we had all the numbers less than -5, so we have to shade to the left. Alright, so this is something kind of new. We haven't had this happen before. In the problems we did at the end of chapter 3, when we drew our number line, we always had one chunk in the middle shaded. Now we've got two disjoint chunks shaded. We got a chunk going to the left and a chunk going to the right. When you have two separate pieces like this shaded, you actually have to write it as two separate answers. So one answer is x is less than or equal to -5. And the other answer is, well, half of the answer, x is greater than or equal to +5. Alright, so that's going to happen when you have an absolute value and you have a greater than. You're going to end up with two disjoint answers, so you're going to have to write two distinct different answers. I see a lot of students try to write this as one complete inequality, and there just isn't a right way to do it. It's got to be written as two answers. Alright, so now let's take something a little bit more complicated here. Absolute value of 2x minus 1 greater than or equal to 11. Again, what you need to recognize is you have an absolute value and you have a greater than. When you have an absolute value and you have a greater than, you write two distinct inequalities. 2x minus 1 greater than or equal to 11, or 2x minus 1 less than or equal to -11. And that's one that causes some confusion. Notice that that inequality symbol flips there. And the way I usually remember that is, it's kind of like when you divide both sides of an inequality by a negative number, you have to change the inequality symbol. Same sort of idea here. When you write the -11, when you change the sign on that number, you have to change the inequality symbol. So hopefully that will help you to remember to do that. Alright, so we have our two separate answers, one greater than 11, one less than or equal to -11. We solve each one individually, see what we get for an answer. Over here we're going to add 1, 2x is greater than or equal to 12, divide, x is greater than or equal to 6. Add 1 over here, 2x is less than or equal to -10, x is less than or equal to -5. Alright, I think that's what makes solving inequalities, absolute value inequalities, a little bit complicated for students. When you have a less than symbol, you do one thing. You trap your thing inside the brackets in the middle. When you have a greater than symbol, you have to split it into two separate inequalities. Alright, now come the somewhat tricky questions. Absolute value of 4x minus 8 less than negative 3. Well, you got to think a little bit about this one. It's kind of like when we had the equation. When we had the equation and I gave you it equals a negative number, we recognize that we had no solution. An absolute value can never equal a negative number. Same sort of thing happens here. On the left-hand side, you have an absolute value. An absolute value is always 0 or a positive number. 0 or a positive number can never be less than negative 3. So our answer there is no solution. Conversely, if I give you an absolute value thing like absolute value of 2x minus 4, and I have it greater than negative 6, well, that's always going to happen. Because again, the absolute value thing on the left is 0 or a positive number. 0 or a positive number is always greater than negative 6. So again, you got to watch out for these problems. You got to watch out for anytime you have an absolute value on one side and you have a negative on the other side. In this case, since we have greater than negative 6, our answer is going to be all real numbers, is how we would write it.